Alright, so now let's apply our quadratic equations to some word problems, most of which are going to involve vertical motion, and then there's a few others. So vertical projectile motion is any time when something's being thrown or cast up into the air, or you can actually throw it downwards from a initial height. This is the equation that we'll be using. Alright, this is our vertical motion equation. And there's three parts to it: this, that, and that. Alright, each of those stand for a different aspect of our vertical motion. The h, or h of t, is the height. So if I tell you a certain time and you know the other numbers, you can plug in the time and solve for a certain height. Or if I know the height, I can back solve for a t and tell me what time something will be at that height. So t stands for time. V here, this v stands for the initial or the starting velocity. Initial velocity. So that's basically its upward speed at the start. And S, which is this term here, it's going to be our third term, is the initial height. The initial or the starting height. Okay, so we have here our the negative 16 t squared. That just accounts for gravity being what's pulling us down. The v, or the vt, that number there is the initial velocity in the upward direction, and the s is the starting height. So here we have a rock is dropped from a riverbank that is 4 feet above the surface of the river. After how many seconds does the rock hit the surface of the water? So we're going to define or say that the surface of the river is equal to 0 height. So the surface of the river is h equals 0. So if it's 4 feet above, that tells us that s, our initial velocity, or our initial height rather, our initial height is 4. Since it's dropped, there's no initial velocity. We didn't throw it up, we didn't throw it down, so there's no initial velocity. So this tells us that the v equals 0. So if we plug that into our equation, we now have h of t equals a negative 16t squared, that'll always be there, plus 0t, right, v times t, plus s, our initial height, is 4. And that simplifies to just a negative 16t squared plus 4. Alright, now we want to find when that is equal to 0, right? Because it says, when does the rock hit the surface of the water? So it hits the surface of the water. That means that h is 0. That's what we're looking for. So we want to set this equal to 0. Alright, so now we're going to use our factoring tools that we've been learning throughout the unit. This almost looks like the difference of squares. This is a perfect square, this is a perfect square. So we could either factor out the GCF or look at it as a difference of perfect squares. Let's start by just looking at a difference of squares. I'm going to factor out a, or is 0 equal? I'm going to factor out a negative 1. And leaves me with a positive 16t squared minus 4. Alright, so now this is the difference of two perfect squares, just like we solved the class before. So that is going to equal, bring it back up here, so 0 equals negative 1 times 16t squared minus 4. Just rewrote it. Now I'm going to say 0 equals negative 1 times, let's factor this. This factors to a 4t minus 4 and a 4t plus 4. So we set each of these equal to 0. 4t minus 4 equals 0. Add 4, and we get 4t equals 4, so t equals 1. And then we have 4t plus 4 equals 0. So I'm setting this equal to 0, and that's this. and I'm setting this equal to 0, and that's this. So what I'm going to do is just solve that, and we get 4t equals -4, so t equals -1. Now we want to know the time. How many seconds does it take the rock to hit the surface of the water? We don't want negative seconds, so our answer is just the t equals 1. That is our answer. Alright, so a football is thrown in the air at an initial height of 5 feet with an initial velocity of 16 feet per second. After how many seconds does it hit the ground? So what we're going to do is try to dissect this. We see initial height of 5 feet and an initial velocity of 16 feet per second. So that initial height tells us that s is going to be a 5 in our equation up here, and then our v is going to be a 16. So that gives us a height in terms of time is equal to -16t squared. That -16 is always in front of the t squared with the vertical motion problems because that's the acceleration due to gravity. And then it's plus, since it's upward velocity of 16t, and then plus it's an initial height of positive 5 feet, so plus 5. Now, when you want to know when it hits the ground, so what we do is we take this and we set it equal to 0. 0 equals -16t squared plus 16t plus 5. Alright, so now we've got to try and solve this. First thing we're going to do is look if there's a common factor. There is no greatest common factor, so we're not going to worry about that. We're going to now look at the things that multiply to give us a, let's see, -16t times 5 is going to be a -80t squared. And they have to add up to a 16t. So this is a bit of review. You guys should already be solid at this. You should know how to do these quite easily. But we're going to be a positive and a negative number because they have to multiply to a negative. And we want the larger of the two to be positive. So if you go through all the factors, you'll discover that it's a 20t and a -4t. We'll multiply to a -80t squared and add to a 16t. So we can then go to our grid, or if you factor by grouping, then fine, do that. I'm going to do it this way. And we get this -16t squared goes here. The 5 goes there automatically. And then we plug in the 20t and the -4t. Alright, so now we factor this all out. Greatest common factor of this column is a -4t. Greatest common factor here is a +5. Greatest common factor here is a 4t. And greatest common factor here is a 1. So that tells us that this equation is the same as 0 equals, instead of this trinomial, we just factored it to -4t plus 5 and 4t plus 1, right, from these. So now we can solve this. We set each of these equal to 0. So just setting this equal to 0, we get -4t plus 5 equals 0. That will solve our equation. Divide both sides by -4. Make sure you're careful of your signs. So we have t equals -5 over -4, which is a positive 5/4. So that's going to be our answer. And then just to show you that this gives us a negative time, which we're not looking for a negative time, 4t plus 1 equals 0. So we have 4t equals -1, t equals negative, divide both sides by 4, t equals -1/4. Alright, so we don't want this one because it's a negative time. So that doesn't make sense for our scenario. We're not looking for backwards in time before the ball was thrown. We're looking after it was thrown, how long does it take to hit the ground? So that's going to be 5/4 of a second. Or you can think of that as 1.25 seconds. There's our answer. So let's do one more word problem that doesn't involve projectile motion. Student council wants to purchase tables for the school lobby. The table comes in a variety of dimensions, but for every table, the length is 1 meter greater than twice the width. Alright, so they just like that proportion for tables. The student council has budgeted for a tabletop with an area of exactly 3 square meters. Find the width and length of the table they can purchase. So basically we have some rectangular table and we want its area. We know the area is length times width, right? So we want its area to be 3 square meters, and we know that the length is 1 meter greater than twice the width. So if this is the width, then the length has to be twice the width, and then 1 meter greater than that is a plus 1. So this is our length, this is our width. So width times length gives us the area. So we want the length times width to equal 3 square meters. So we want to set that equal to 3. So now we're going to follow our 5 steps. We're going to set everything equal to 0, so we're going to distribute this and then set it equal to 0. So I distribute the w, and I get 2w squared plus w equals 3. I have to subtract the 3 to get it equal to 0, and I have 2w squared plus w minus 3 equals 0. Alright, so now we have one of the problems that we just learned to solve a few days ago. So we're going to factor this. At this point you should know how to factor that, so I'm not going to go through all the steps. If you want to pause the video right now and try to factor it on your own with the table and then the grid method, that's fine. But we're going to get a 2w and a w, and then that's a minus 1 and a plus 3 there. So that's how that factors. And then what we're going to do is we set each of these equal to 0. So if we set this equal to 0, 0 times anything is 0, that solves it. So 2w plus 3 equals 0. Minus 3, minus 3. 2w equals negative 3. Divide by 2, divide by 2. W equals negative 3 halves. Well, a negative 3 halves for a width, a negative anything, any negative number for a width doesn't make sense. So though that does solve this algebraic equation, it doesn't help us for our problem, so we don't want that one. So then we're going to set this equal to 0. So w minus 1 equals 0. W has to be 1. So the width is 1. Now it says find the width and length. So the width is 1. The length, we have to plug in the width to find the length. It said it was 1 meter greater than twice the width. So if we plug in a 1 here, we have the width equals 1 and the length equals 2 times 1 plus 1, which is 3. So that is our complete answer, the width and the length. Alright, so now you guys can try this problem. This is a projectile motion problem. Take notice of the 10-foot platform, the initial velocity. Make sure you remember initial velocity goes here, initial height goes here. And go ahead and solve that, and I'll see you in class tomorrow.